Hi and welcome to my YouTube channel. This is Delsquared and this time we have made a rotary display using an Atmega 8 processor. This is our design. Here we have a battery, an Atmega 8 microcontroller board that we have soldered, and then we have an array of LEDs, and this is an infrared sensor. This infrared sensor gives signals to the microcontroller to start the process. If the sensor doesn't give any signal, then the LEDs are not lit. And there is a very big problem while doing this. We encountered this problem while doing this, and that was mounting this acrylic rod firmly onto the motor shaft. But that problem was solved when we did this. We stuck the acrylic rod to this wheel, and then we stuck the wheel to the motor shaft. So that bypassed all the problems. And this is the main power supply jack, and this is the battery, 9 volts battery. And if you can see, there is one very important consideration while mounting these components on the acrylic rod, because this acrylic rod is going to rotate like this. So the point is that if you place this battery here, and to be more specific, we have placed this battery here and only here because this is the place which is in axis with the center of or in other words the moment of inertia or the axis of rotation of the shaft. So here the moment of inertia contributed by the small battery will be smaller than the moment of inertia contributed whenever it is away from the shaft. So that is very important. You have to place this battery here, and these microcontroller and the sensor and the LED arrays need not be given that consideration because of the fact that they are very light in weight, whereas this 9 volt battery is a little bit heavy, and that will cause a vibration in the motor which will eventually cause it to break. So we wouldn't want to do that, so this is one easy way. And if you still are not getting the right point where to mount this thing, then you can vary the point at which this whole shaft is mounted. You can displace it over this so as to get a perfect sync. And whenever you rotate it, you should not feel any kind of an up or a down pull or a push, because if that happens, then it means that your moment of inertia is disturbing. I mean, the centrifugal force generated by one component on this thing is disturbing your system, so that should be avoided. And if you can see, whenever I power this up, you can see that nothing will happen because the sensor is not giving any cue for the process to start. But whenever I give this cue, this happens. Or whenever the sensor reads the signal, see, whenever the sensor reads the signal, it glows. So that means that that a digital pulse has been sent to this microcontroller, and whenever that receives, then it will start. You can see. So this is what is happening. So this is the most important point to be noted in this. So let's see what will happen when we run this. We are going to run our first code. So here you can see that this motor has been mounted onto this desk, and we have given the power supply, and you can see that this here is the point where the digital sensor will receive the cue to start the process. Whenever the sensor is on the white region, it will light up the LEDs, and whenever it is not, it will remove the power on the LEDs, and that is going to happen. So I am now going to switch this on, and now you can see that there are characters being displayed, and this red streak here is the point where the sensor is being triggered. And whenever I switch this, now you can see that the characters are being displayed with a little bit of space. But now, whenever I speed up the process, I'm giving a 12 volt supply to the motor. The font will increase, and that is what is expected to happen, and that is what is happening. So this is the first test.